Hello students, welcome back to the 8th video of this playlist. In this video, we will be discussing question number 17 from the most recent past paper of Physics Unit 2, which is the October 2024 paper. So let's get started with question number 17 of this paper. Okay. So here the question says the refractive index of water is 1.33. So part A is asking to calculate the speed of light in water. Okay. So basically we have to use the formula here relating the refractive index and speed of light. Okay. So this is nothing but this formula, N equals to C over V. Okay. So we need to where C is the speed of light in vacuum and V is the speed of light in a specific medium. So here the specific medium is water. So we have to make V the subject. So V equals to C over N. So C is 3 times 10 to the power 8 over 1.33, that much meter per second. So you will get the speed of light in water. It is 3 times 10 to the power 8 divided by 1.33. So that would be, if I write, it is basically 2.25563908 times 10 to the power 8. That much meter per second. Okay. So we can write it to three significant figures as 2.26 times 10 to the power 8 meter per second. Okay. So it is basically 2.26, or you can write to, okay, they wrote to 2 decimal place or 3 significant figures. So we can write it to 2.26, that is 3 significant figures. In its standard form, it is 2.26 times 10 to the power 8 meter per second. Fine. Okay, next is part B. So part B is basically a star marked question, which is called as asterisk type question. So here the question says a person is swimming underwater in a lake. The person looks up towards the surface. Three rays of lights A, B, and C are incident on the surface of the water as shown. Okay, you can see in the figure three rays of light, ray A, ray B, and ray C, are incident at the water surface. Okay, fine. Each ray changes direction at the surface of the water. Okay, light from rays A and B reaches the person's eyes. Most of the light from ray C does not reach the person's eyes. Okay, so ray A and ray B reaches the person's eyes, but the light from ray C, it does not reach the person's eyes. Okay. So part B is asking to explain the paths of rays A, B, and C after each ray changes direction at the surface of the water. So this is for 6 marks we have to explain. Okay. So we can see that there are 3 rays, ray A, ray B, ray C. So we will have to explain in a very disciplined way and in a well structured pattern. Okay, so for ray A we will consider 2 points, for ray B we will consider 2 points, and for ray C we will consider 2 points, for total 6 marks. Okay, so at first consider ray A. So we can see that ray A, it is moving from an optically rarer medium to an optically denser medium, right? So as it is incident on the surface of the water, so it will get refracted towards the normal, and therefore it will reach the person's eyes. Okay, so the first point we can tell about ray A is that ray A is passing from an optically rarer medium to an optically denser medium. This is the first point. Okay, so at the surface of the water, ray A will be refracted towards the normal. Okay, it will get refracted towards the normal. So we could see that ray A was going away from the, if it would follow a straight way, okay, without any refraction, then we could see that it was not able to reach the person's eyes, right? But as it is refracted towards the normal, therefore it reaches the person's eyes. Hence, reaches the person's eyes. Okay? Okay. So we have considered 2 points for ray A. Next, ray B. Okay. So the question has said that ray B has also reached the person's eyes, right? So that means ray B is passing from water to air, right? So from denser to a rarer medium. So we have already said that earlier. So we have to, for ray B, we have to mention that ray B is incident at the water surface at an angle greater than the critical angle for air water interface. Okay, so that's why it will get total internally reflected, and that's how it will reach the person's eyes. Okay, so we can't say that ray B is passing from a denser medium to a rarer medium, because we have already said that in the first uh, point. Okay, so ray for ray B, we have to say that ray B is incident on the water surface at an angle greater than the critical angle for water air interface. Okay, so the second point, the ray B will be total internally reflected at the water surface, and hence reaches the person's eyes. Okay, so we have said 2 points for ray B, and at last for ray C. The question says that for the ray C does not reach the person's eyes. Okay, so we can see that ray C is also moving from, it's passing from water to air. Okay, so but for ray B, it was incident at an angle greater than the critical angle for water air interface, but ray C, it is incident at an angle less than the critical angle for water air interface. That's why it is not reflected. Therefore, most of the ray C, it is being refracted through the water surface. Okay, that's what we will say here. Ray C is incident at the water surface at an angle less than the critical angle for water air boundary or interface, whatever you say. interface. Okay, so most of the light from ray C is refracted at the water surface. Therefore, hence, does not reach the person's eyes because it is going away to the air, right? Through the air medium. Eyes. That's it. These are the 6 points we can write for 6 marks. And yeah, definitely you have to consider a disciplined pattern, a well structured answering pattern. Okay, fine.